This is day 12 of Advent of Cyber 2025, and this challenge is called Christmas Tree Farm. You're almost out of time, but there can't be much left to decorate. Although there are no stairs, elevators, escalators, tunnels, chutes, teleporters, fire poles, or conduits here that would take you deeper into the North Pole base, there is a ventilation duct you jump in. After bumping around for a few minutes, you merge into a large, well-lit cavern full of Christmas trees. There are a few elves here frantically decorating before the deadline. They think they'll be able to finish most of the work, but the one thing they're worried about is the presents for all the young elves that live here at the North Pole. It's an ancient tradition to put the presents under the trees, but the elves are worried they won't fit. The presents come in a few standard but very weird shapes. The shapes and the regions into which they need to fit are all measured in standard units. To be aesthetically pleasing, the presents need to be placed into the regions in a way that follows a standardized two-dimensional unit grid. You also can't stack presents. As always, the elves have a summary of the situation, the puzzle input, for you. First, it contains a list of the presents' shapes. Second, it contains the size of the region under each tree and a list of the number of presents of each shape that need to fit into that region. So for example, we have 0, then there's hashes and dots, and 1, 2, 3, 4, 5. Then we have 4 by 4, 0, 0, 0, 2, 12 by 5, 1, 0, 1, 0, 2, 2, and so on. First section lists the standard present shapes. For convenience, each shape starts with its index and a colon. Then the shape is displayed visually, where hash is part of the present and dot is not. The second section lists the regions under the trees. Each list starts with the width and length of the regions. So 12x5 means the region is 12 units wide, x units long. The rest of the line describes the presents that need to fit into that region by listing the quantity of each shape. So 101032 means you need to fit one present with shape index 0, no presents with shape index 1, and so on. Presents can be rotated and flipped as necessary to make them fit in the available space, but they have to always be placed perfectly on the grid. Shapes can't overlap. That is, the hash part from two different presents can't go in the same place on the grid, but they can fit together. That is, the dot part in a present shape, this diagram, does not block another present from occupying that space on the grid. The elves need to know how many of the regions can fit the presents listed in the above example. There are 6 unique present shapes and 3 regions that need checking. So the first region is 4 by 4. In it, you need to determine whether you could fit 2 presents that have shape index 4. After some experimentation, it turns out that you can fit both presents in this region. And here's how you'll do it. There's present, first one like that, the second one be like that. Second region, 12 by 5, which has these presents. It's 12 units wide, 5 units long. In that region, you need to try to fit one present with shape index 0 and so on. Turns out that these presents can all fit in this region. Here is one way to do it. Again, using different capital letters to represent the presents, like so. And then the third region, which is 12 by 5, has these presents. It's the same size as the previous region. The only difference is that this region needs to fit one additional present, which is shape index 4, but it cannot fit. So in this example, 2 regions can fit all of their presents. Consider the regions beneath each tree and the presents the elves would like to fit into each one of them. How many of the regions can fit all of the presents listed? So I can pretty much say straight away, this is probably a challenge I can't complete myself. Or if I do, it'll take too long. So we will accept the help of ChatGPT, but we will do it in a way where we actually understand what it is we're doing. So let's first grab the input, and of course first thing we need to do is create the inputs. So let's do var blocks is equal to, and this will be a new list of strings. So each block will be represented as a list. So each character here was each line. I have to find out what ChatGPT says, but we'll have a list of them. And it has a variable for CUR, which is the current block. So that'll be just a list of string. And now it's time to go for each line in input. And what it's saying for this is if string dot is null or white space, then make it a line. No, if line is null white space, then take a look at if the current count is greater than 0. It is blocks dot add current. Okay, so we're building up the current block. And then, so we build up the current block and then we add it to the blocks list. That's what's doing. So if it's a new line, it should be like here. If this is full, if it's greater than 0, then we've filled up the current block, and we're adding it and then resetting it. So equals new string. And if it's not white space, go down here and do current add line. Then outside of this loop, if current.count greater than 0, then we add it to the blocks. So we're now creating a variable which records how many different block shapes there are, which is just blocks.count, then -1. Once we have that, GPT wants us to create, pre-compute all possible rotations of the shapes. So also shape transforms. This is a new list of int x, int array of y's, then int w, int height, and then we are creating a static bool array which then rotates shapes by 90 degrees. So rot 90, you're passing a bool array called g, and you do int n is equal to g dot get length of 0, and var r is equal to new bool nn, and for int y is equal to 0, y is less than n, y plus plus. Then inside of that loop we do for int x is equal to 0, x is less than n, x plus plus. Then r, we do r, and then the index is n, -1, y, x is equal to gxy, and we return r. So how does that work? So we've got g, this is the shape we're passing in. We've got g, we're grabbing the length, creating a new bar bool, which is the size of it, and then the x here is then the x here. Okay, that makes sense. N -1 minus y. I suppose that makes sense because when you're rotating by 90 degrees, the x, let's say the y value, then becomes the x value. So you might have a value that's down here, then that becomes the x up there. Okay, so that makes sense for rotate 90 degrees. Also creating a boolean one for this, which is to flip it on the x-axis. Flip x, and there'll be a lot of the same repeated code, so I may as well just copy from there, copy there, getting this, do that. Same thing with the y, same thing with the x, but now it's n -1 minus x and y. So we've got that, and now we are creating, converting a grid to a string key, because there'll be a lot of, we want to keep track of. Okay, so now we're going to be creating a function which creates a string representation or key of the boolean array. So bool comma g, a lot of the same code, so copy it, say int n equals length, but now we're going to do var is equal to new character array, which is length of n times n. Let's do int k equals 0, for y this, then for x, but now we're doing cars a plus plus equal to gxy, and if it's true we do a hash, or if it's false it's a dot. So basically just turning the shape representation to a string, we then return that character array to a new string. Okay, it looks like we're now getting into the bulk of it. So int b is equal to 0, b is less than shape block count b plus plus. So we're going to be grabbing the block for this current iteration, and int shape index is equal to int.par block 0.trim n. Okay, so we've got the block, and it's taken into account that first row is actually the index of the block. So it's just getting rid of the colon, grabbing the remainder, which is the number, and then turning that to an int. So we now got the actual index of the shape. So creating base grid is equal to a new bool of 3, 3. So every shape is 3 by 3. Actually, let's just double check the real input. Okay, yeah, these shapes all appear to be 3 by 3 as well, but there's far more trees than our test. Okay, so back to here, we've got our base grid, and we're going to be iterating through the grid. So for int y equals 0, y is less than 3, y plus plus, and for int x is equal to 0, x is less than 3, x plus plus. Then in our base grid of x and y, we are setting that as our block, index of 1 or plus y, because for this at the top here, so we start at 1, and then this is the y axis, and then within here we do x, and our base grid is a boolean array, so we do if that is equal to hash, then we set that. So we've now created the base grid for the block, and we're now creating a hash set for scene, which will take in string, and then creating a list for transforms, and this will be int array for x's, int array for y's, and then int w, int h. So this was for the shape transforms, so this one holds all transformations, and then now we're actually going to be creating them for the shape. So for each bool flip in new array, which holds false true, then we're creating a bool array for g, which is equal to flip. If we are flipping, we're doing flip x with the base grid. Otherwise, it is just the base grid. And now we're going to be rotating it 4 times. So for int r is equal to 0, r is less than 4, r plus plus. If r is greater than 0, then g is equal to rot 90g. So obviously on the first rotation, or if you don't rotate at all, no need to rotate again. So keep it as it is for the first iteration of this. Then for subsequent ones you do then rotate it. Then do string key is equal to key and passing g into it to create the string representation. Now we're checking if we've already seen the key being added. So we're trying to add it, but if it already exists, then we just continue, so we don't go any further with it. We're now creating, not sure what this PTS is it, whether it's parts or points, but it's int x, int y, so probably points. Now for int yy equals 0, yy is less than 3, yy plus plus, and it will be the same thing again, but for int x is equal to 0, and this needs to be xx, xx less than 3, xx plus plus, and we go through that. Now if g xx yy, as in its block location, doing points dot add, and then xxyy. We're creating the points for the current rotation. Now we are creating minimum x, which is points dot min, and then from within the points, grabbing the smallest x, and then it'll be the same thing, but for y, I is less than points dot count. So I forgot to int I, and I is less than that, I plus plus, and points I is equal to points I dot x minus min x, and comp, okay, why didn't that work? Min x, oh, I did mix x, okay, let me change that. Got min x min y properly now, and then points I dot y minus min y. Next we're going to produce the width, which is points dot max p dot x, and we're going to add 1 to this as the sizes are inclusive. And now we're doing the same thing for height with y. And now that we've retrieved all these values, we're adding it to the transforms. So add that in. So we have points dot select p dot x, and turning that to an array. Now we're doing the same thing for y. Now width I. Okay, so we've created all the transforms for the shape, so we'll iterate through this loop, going through every single block, creating the grid for it, preparing the transformation, going through and getting every possible permutation of it, then adding the transformations to that list. At this point, while shape transforms count is less than equal to shape index, shape transforms dot add new. I'm not exactly sure what that's for. Actually, let's see, what loop are we in? Actually, I think I'm meant to still be inside of this loop. Oh wait, yeah. So shape transforms and then shape index, because that's the shape we're currently on. And we set that to transforms. So this so far has all just been preparation, just taken a long time. And I'm very happy I got ChatGPT to do this, because I wouldn't have been able to solve that. So now we'll create variable answer, started at 0. Let's just chuck it here. Now we're going to go through each line in blocks. Interesting, it's doing caret 1. Not too sure what that does, but we grab the parts, which is equal to line dot split colon 2. What does that count? Dimensions equal to parts 0 dot split x. Okay, so we're at this point now, actually creating the grids of the trees that's going to be used. So we're still not completely ready for actually solving it. With that, we'll do int W is equal to int.parse, dimensions 0. Then it will be the same thing for the height, but with the first, or index 2, or 1. So creating an int array called needs, which is which shapes need to be used. This is using parts 1, and we are going to split on space and using the string options to remove empty entries. So we should only have the numbers themselves. We will then dot select, so they'll have the string for the number, and then we're going to do int parse, so runs that on every single number, and then we convert to array. We are creating a variable called total field, initializing it 0, and then we're going to be iterating through need. Let's change it to need, not needs, and I++. So we're iterating through all the needs, and then grabbing total field is equal to need I times shape transforms I 0 dot access dot length. I gotta see what's happening. So if total field is greater than width times height, then we continue. So what we just did there was we've got the width and height of the current tree. We then retrieved all the shapes that are required for the tree, so these numbers, and looking at the size of those, if the size of that, or the total shapes needed, spaces within the shapes, exceeds the area of tree, then we're just skipping it, as we know it's impossible to do. So once we're past this point, we know that there is a possibility. So var rows is equal to new long each var placements by shape is equal to new list int y long masks, and this is being initialized with the length of need. So for int s is equal to 0, s is less than the length of need, s++, we are placements by shape on s, we are initializing it, so setting it to new, and for each transformation in shape transforms, grabbing s, we are going to be iterating through it all. Int oy is equal to 0, oy is less than equal to height minus transformation height, and then oy++, and then doing another int ox is equal to 0, ox is less than equal to width minus transformation width ox++. So I think what's happening is we're using binary math to represent what the shape location or something. So using a ulong, you're getting the full, I think it's a 64-bit of a number. So let's iterate through the x's dot length I++ and masks tysi is pipe equals 1 ul and binary math with transformation xs I plus ox. This needs to be inside of here plus ox. Why did it type of tr? And that's meant to be ys. There you go. So once that's done, placements by shape s, we add to it, and it's going to be oy masks. So not 100% sure, but definitely no, I never would have got that. So now we're going outside of this main for loop. Well, not the main one, but this one here. We are creating a memoization. So dictionary, which takes in a string and returns a bool. So we're creating a bool function called fits, which takes in int y and ulong array m. So for int equals int I equals 0, I is less than m dot length I++, and if rows y plus I and m1 does not equal 0, return false. We need both of those parentheses. So if at any point this condition is true, I'm getting an error with it. It's meant to be just 1. Oh, my bad. This is meant to be parentheses here and then here. So if at no point it returns false, we then return true. Now we're doing a void apply, which takes an int y ulong m, and it'll be same for loop condition. But for this one, rows y plus I, and the pipe equals m1, and void undo, which will be a lot of the same right here. This one is this one, but with a caret instead. So I'm assuming, so the binary math here, scrap the mask, it's applying that binary math to this row, and then in this one it's undoing it, which you can guess from the name. And now we're going to be creating a large Boolean function called solve. So this is what actually runs it. So it's doing string key is equal to string.join by a comma rows. It's adding a pipe plus string.join by a comma and need. So if memo.try get value key out bool v. So if this has already occurred, I'm assuming. So with the key, we've already done that exact same thing. Turn v. Otherwise bool any left is equal to false. And for int I is equal to 0, I is less than need dot length I plus plus. And if need I is greater than 0, any left is equal to true, then break from the for loop. And back here, if it's still not any left, return memo key is equal to true. If there's nothing left, then I'm assuming it's saying was successful. So we're specifying that this current key is successful and it's returning true, but it wasn't successful. Int chosen is equal to -1, and int best is equal to int.max value. And doing for int s is equal to 0, s is less than need.length s plus plus, and inside of if need s is greater than 0 and placements by shape s count is less than best is equal to placements shape s dot count, and chosen is equal to s. Not sure what the purpose of that is, but sure. So outside of that, doing a for each var ym in placement shapes chosen. If not fits, ym is continuing, need chosen is being decremented, then apply ym. Now if solve undo ym need, just grab this, need plus plus, and then return memo key equals true. But if it wasn't, we still do this. And if that for each loop then finishes without having sent true here, we then specify that this key cannot fit under the tree, so we set it to false. And with that, go back to here and we run solve, and if it returns true, we then do answer plus plus. Yeah, so ChatGPT wrote all this, and I'm pretty sure it does work, but I was barely grasping what any of this was, so I definitely wouldn't have been able to figure that out myself. Let's try run it. We have the test, so let's run it on that, see what we get. We got 2, which was correct. So let's grab our actual input, put that into here, and try again on that. And with that, we've got 5, 6, 7. So let's enter that in and see if it was correct. Hopefully ChatGPT was correct, and it was, which is cool. Didn't have a clue what that code did, but hopefully someone else does. So let's go on to part 2 now. And the elves thank you profusely for the help and start rearranging the oddly shaped presents. As you look up, you notice that a lot more elves have arrived here at the Christmas tree farm. In fact, many of these new arrivals look familiar. They're the elves you helped while decorating the North Pole base, right on schedule. Each group seems to have brought a star to put atop of the Christmas trees. Before any of them can find a ladder, a particularly large Christmas tree suddenly flashes bright when a large star magically appears above it. As your eyes readjust, you think you notice a portly man with a white beard disappear into the crowd. You go look for a ladder. Only 23 stars to go. You have enough stars to finish decorating the North Pole. Alright, let's go finish decorating the North Pole. And that is that. You help the elves decorate the Christmas trees with all 24 stars. Now the elves will have plenty of time to prepare for Christmas, and you get a well-deserved break. So that is Advent of Code 2025 complete. If you like this video, make sure to like and subscribe.